All right, today what we're going to be talking about is bisectors of triangles. Bisectors of triangles. So the first thing we're going to do is go through a couple vocab words, and then you'll have a few theorems that you're going to need to write down in your notes that we will be using further on in this chapter. All right. So the first vocab word we have is a perpendicular bisector. And a perpendicular bisector states that a segment, ray, or line that is perpendicular to a segment at its midpoint. All right. So for example, CP is the perpendicular bisector of AB, which makes AP congruent to PB. Okay, so it makes these two segments congruent. All right, now we have two theorems in this chapter that we're going to be going over. We have Theorem 5.2, which is the perpendicular bisector theorem, which states in a plane, if a point is on the perpendicular bisector of a segment, then it is equal distance from the endpoints of the segment. So for example, in this picture we have if CP is the perpendicular bisector of AB, then CA is equal to CB. Okay, so these two now become congruent. All right. All right, and then the theorem 5.3 is the exact opposite of that. It's the converse of the first theorem. So it states, in a plane, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So, for example, if AD is congruent to BD, then D must lie on the perpendicular bisector of AB. All right, so with these two theorems in mind, we have some examples we'll work through. So our first example says BD is the perpendicular bisector of AC. So we want to find how much AD is. Well, according to our theorem 5.2, the perpendicular bisector theorem, we know that CD is congruent to AD because BD is the perpendicular bisector of AC. So we can actually set these two equations equal to each other. So we have 3x plus 14 equals 5x. Combine like terms, so now we have 14, I'm subtracting 3 to both sides, and then I'm going to have 14 equals 2x. So then x will equal 7. Plug 7 in for x in AD, and you will get 5 times 7, so AD will equal 35. And that'll be our answer. Okay? All right. So this next example states in this diagram, JK is the perpendicular bisector of NL, and we want to find NK. So we can then go through and do the exact same thing. We can set 6x minus 5 equal to 4x minus, plus 1. Solve for x, plug x back in for that, and then we can sorry about that. All right, so explain why M is on JK. So then we can, the reason M is on JK is because this is a perpendicular bisector. These two are congruent. We then also know that NM and ML are congruent. They're both equal to 8. And according to the converse of the perpendicular bisector theorem, M then has to lay on the perpendicular bisector because the two sides of our little triangle right here are congruent. All right. All right, so that's all we're going to talk about today. We're just going to talk about those two theorems. In the next one, we'll go into angle bisectors. For today, we're just going to stick with the line bisector. So please come to class with any questions, and we will go from there.